Ferrari has just completed the first Formula One laps around Madrid's new motoring circuit, and what they discovered could completely change the SF-26 before Spa. This was only a restricted filming day, with limited mileage, special tires, and no full race simulation. But Ferrari still gained something no rival had: real track data, real driver feedback, and the first chance to compare the motoring simulation with an actual Formula One car. The timing makes this even more serious. Only days earlier, Lewis Hamilton admitted that a setup mistake at the British Grand Prix made his magic disappear after taking sprint pole. Now Ferrari may finally know why. Because the most alarming result was not a slow lap. It was evidence that the SF-26 may already have the speed, but only inside a performance window so narrow that one wrong adjustment could destroy everything at Spa. And the hidden clue from that first lap could reveal whether Ferrari has found a breakthrough or exposed its biggest weakness. Subscribe to the channel. To understand why Ferrari's first laps around the motoring mattered so much, you have to ignore the one thing everyone looks for first: the lap time. Because on a filming day, the stopwatch can be almost meaningless. Ferrari was not running a full qualifying simulation. The mileage was limited. The tires were not the same as the normal Grand Prix tires. The team was not free to spend the entire day chasing the fastest possible setup. So if someone tells you Ferrari proved the SF-26 is suddenly the quickest car on the grid, that claim goes far beyond the information available. But this is where the story becomes more interesting. Ferrari did not need a spectacular time. It needed an honest reaction from the car. A filming day is one of the first moments when the engineers can compare months of computer work with the real machine moving on real asphalt. Inside the factory, Ferrari can model almost everything: airflow, suspension movement, brake temperatures, tire loads, energy use, the way the car should respond when the driver turns, brakes, and accelerates. But a simulation is still a prediction. The first real lap is the moment reality answers back. And reality is never perfectly clean. The surface has bumps. The wind changes. The tires move under load. The car vibrates. The driver makes tiny corrections that no computer model can reproduce exactly. That is why the first lap matters. Not because it proves the car is fast. Because it reveals whether Ferrari understands what it has built. Imagine designing a key from perfect measurements. Every number says it should fit. Every angle looks correct. Then you place it inside the lock. If it turns smoothly, you trust the design. If it sticks, even slightly, the entire calculation must be questioned. Ferrari's first motoring lap was that moment. Did the SF-26 behave exactly as the engineers expected? Did the front respond cleanly? Did the rear remain stable? Did the balance move in the predicted direction? Or did the car produce a reaction that forced Ferrari to reconsider its setup? That is the real tension. Because Ferrari arrived in Madrid after one of the most painful reminders of how quickly performance can disappear. At the British Grand Prix, Lewis Hamilton had found enough confidence to take sprint pole. For one session, the car gave him what he needed. The front responded. The balance made sense. The limit felt reachable. Then the setup direction changed. Hamilton later said his magic had disappeared. That phrase sounds emotional. But beneath it is a serious engineering warning. A Formula One driver does not lose speed without a reason. The driver can only use the performance the car allows him to access. When the balance feels predictable, he commits. When the car begins sending mixed signals, he hesitates. And hesitation in Formula One does not always look dramatic. It appears in tiny moments. A slightly earlier lift. A slower steering input. A delayed return to the throttle. One extra correction at the exit. A driver can lose only a fraction in each corner. But across a full lap, those fractions become the difference between attacking the front row and fighting much further back. That is why Ferrari's real problem may not be a lack of speed. It may be the difficulty of holding on to that speed. And that is far more alarming. A slow car gives the engineers a clear mission. Find more performance. A car that is brilliant one moment and confusing the next creates a deeper problem. The team knows the speed exists. The driver has already felt it. The data has already recorded it. But Ferrari may not know how to keep the car inside the exact conditions where that performance appears. This is called the operating window. The idea is simple. A wide operating window means the car works well across many different situations. Hot track, cool track, fresh tires, used tires, high fuel, low fuel, different wind directions, different setup choices. A narrow operating window means everything must be almost perfect. The temperature has to be right. The tires have to be right. The ride height has to be right. The balance has to sit in one tiny area. Move outside that area, and the performance disappears. It is like standing on a narrow beam. When you are in the center, everything feels controlled. One small step to either side, and suddenly you are fighting to stay upright. Ferrari may already know where the fastest version of the SF-26 lives. The real question is whether that place is wide enough to survive an entire race weekend. And Spa will test that brutally. Because Spa does not ask the car to do one thing well. It asks the car to do almost everything. The SF-26 needs low drag on the straights. It needs stability in high-speed corners. It needs strong braking confidence. It needs traction. It needs a balance that survives elevation changes and changing weather. Ferrari cannot maximize all of those things at once. More wing creates more grip, but it also creates more drag. Less wing improves straight-line speed, but it can make the car nervous in the corners. A sharper front end can help rotation, but it can make the rear harder to control. More rear stability can protect the driver, but it can also make the car reluctant to turn. Every setup choice gives Ferrari something. Every setup choice takes something away. The challenge is not removing compromise. That is impossible. The challenge is choosing a compromise the drivers can trust. And this is why Madrid became so valuable. Ferrari had a new circuit, a controlled program, and a chance to observe the car without the chaos of a normal Grand Prix weekend. No qualifying countdown. No rival lap times forcing an immediate reaction. No need to chase one dramatic number. The engineers could focus on behavior. Did the car give the same answer twice? Did the same corner produce the same response? Did a setup adjustment create the result Ferrari expected? Did the driver's feeling match the sensor data? That last point is crucial. A driver may say the front feels stronger, but the data might show that he entered the corner more slowly. A driver may say the rear feels calmer, but the car may be losing rotation. A setup can feel safer without being faster. It can feel sharper while damaging the tires. It can improve one section while creating a larger loss somewhere else. That is why Ferrari needed the complete pattern. Not one impression. Not one lap. A pattern. If the driver says the balance improved, and the data shows cleaner steering, earlier throttle, and fewer corrections, Ferrari begins to trust the result. If the feeling improves but the performance disappears, the team must ask why. And if the data shows something completely different from the simulation, the concern becomes much deeper. Because that would not only question the setup, it would question Ferrari's understanding of the car. This process is called correlation. The word sounds technical. The meaning is simple. Did the real SF-26 behave the way Ferrari predicted? When the answer is yes, development becomes easier. The engineers can trust the simulator. They can prepare future upgrades with greater confidence. They can arrive at Spa knowing that a small change should create a predictable result. When the answer is no, every decision becomes more dangerous. Was the setup wrong? Was the simulation wrong? Was the new circuit surface creating the problem? Was the driver still learning the layout? Was the wind affecting the car? Or was the filming day program too limited to reveal the full truth? One unexpected movement can create 5 different investigations. And Ferrari had another disadvantage. There was no rival reference. Ferrari became the first Formula One team to run at the Madrid. That gave it exclusive information. But it also meant the team was learning alone. If one corner felt unusual, Ferrari could not compare its reaction with another Formula One car. If the braking zone felt unstable, the engineers could not ask whether every team would face the same problem. If the surface created strange tire behavior, there was no previous Grand Prix data to study. Being first is powerful. It is also risky. Ferrari had to decide which signals belonged to the car and which belonged to the circuit. That is why repetition mattered more than speed. If the same weakness appeared again, it became harder to dismiss. If a setup change removed it, Ferrari learned something. If both drivers identified the same behavior, the evidence became stronger. And if the real data matched the simulation, the team gained the one thing it desperately needed before Spa. Confidence. Not emotional confidence. Technical confidence. The confidence to make a change and understand the result. The confidence to move the setup without fear that the entire balance will collapse. The confidence to believe that Hamilton's missing magic can be recovered deliberately, rather than appearing by accident. Because that is the uncomfortable truth behind Ferrari's situation. Hamilton's sprint pole showed the car could produce something special. The setup miscue showed how fragile that performance may have been. And Madrid gave Ferrari a chance to investigate whether the problem was one wrong decision, or something deeper inside the SF-26. A wrong setup can be reversed. A narrow operating window is much harder to fix. If Ferrari's Madrid data showed the car behaving logically, then the British Grand Prix may have been a warning, not a disaster. The foundation would still be sound. The team could return to a known baseline. It could make smaller adjustments. It could protect the balance Hamilton trusted. It could give Charles Leclerc room to adapt the car around his own style. But if the same sensitivity appeared again, the concern would become far more serious. Then Ferrari would not be dealing with one bad setup choice. It would be dealing with a car that may only perform inside a tiny range. And Spa could expose that weakness immediately. The long straights would punish excess drag. The fast corners would punish instability. The braking zones would punish a lack of confidence. The changing conditions would test whether Ferrari can keep the tires, balance, and ride height inside the correct window. One small mistake could spread across the entire lap. And that is why the Madrid filming day cannot be dismissed as promotional running. Ferrari was not simply introducing Formula One to a new circuit. It was listening to the SF-26 at a moment when every answer mattered. The team needed to know whether the car responds logically, whether the speed can be repeated, whether setup changes improve the car without creating a larger weakness, and whether the performance Hamilton found can survive once Ferrari begins adjusting the car for Spa. The most important result was never the fastest lap. It was whether Ferrari removed uncertainty. Because the team that understands its car can respond. The team that does not understand it can only react. And Ferrari has no room to spend another weekend reacting. Somewhere inside those first Madrid laps, the engineers may have found the first real clue. Either the SF-26 has a stable foundation that Ferrari can finally build around, or the car's strongest performance remains trapped inside a window so narrow that Spa could close it in a single session. And the next stage would reveal which possibility Ferrari was truly facing. Then came the part Ferrari could not afford to misunderstand. The first laps had created information. Now the engineers had to decide what that information actually meant. Because data does not speak with one voice. One number can look positive. Another can point toward a hidden weakness. The driver can feel more confident, while the stopwatch shows no improvement. The car can gain speed in one section, then lose even more somewhere else. And this is where a promising filming day can become dangerous. Ferrari had to separate a real breakthrough from a temporary effect. Fresh tires can make a car feel sharper. A lighter fuel load can make it change direction more easily. A favorable wind can improve one part of the lap. A new surface can offer more grip in one corner, then less in the next. None of those things proves the upgrade has worked. They only prove that something changed. The engineers needed to find the cause. That is much harder. Imagine walking into a room and noticing that it suddenly feels warmer. Maybe the heating was turned up. Maybe sunlight entered through the window. Maybe more people came inside. The result is obvious. The reason is not. Ferrari faced the same challenge with the SF-26. If the car felt more stable, was that because of the setup? Was it because the driver was still below the limit? Was it because the moderating surface suited the car? Or was Ferrari finally seeing the benefit of a development direction that could matter at Spa? One answer would create confidence. Another would create false hope. And false hope is one of the most expensive mistakes in Formula One. Because once a team believes it has solved a problem, every later decision begins from that belief. The wing level changes. The ride height changes. The suspension settings change. The driver adapts. The engineers begin building the next setup around the new direction. But if the original conclusion was wrong, Ferrari could arrive at Spa with the entire car moving toward the wrong target. That is why the team needed a reference. A known configuration. A known balance. Something the engineers already understood. Then Ferrari could compare the new behavior against it. Did the car brake more consistently? Did the front respond earlier? Did the rear remain calmer as the driver applied power? Did the improvement appear in several corners, or only one? And most importantly, did it return when the car went back onto the track? That final question decides everything. A real improvement can be repeated. A misleading one often disappears. Ferrari needed to see the same answer more than once. Not because repetition guarantees success. Because repetition removes uncertainty. And uncertainty was already Ferrari's biggest enemy. Hamilton's British Grand Prix experience had shown how quickly a strong condition could be lost. He had found the balance. He had produced sprint pole. Then the setup changed, and the connection disappeared. That raised a painful possibility. What if Ferrari had found the right answer at Silverstone, but did not fully understand why it was right? That would explain how the team could move away from it so easily. The performance existed. The understanding did not. And when understanding is missing, speed becomes fragile. It becomes something the team discovers instead of something it controls. That is the difference Ferrari needed to eliminate before Spa.